Question 18 on exam 2 asks us to find and interpret R squared. So to start, we enter our values into the calculator by going to Stat Edit and then putting the total fat values into L1 and the calorie values into L2. Then we go to Stat Test and then linreg t-test, where you put your x list as L1, your y list as L2, and your frequency is 1. And at the bottom of the screen, you get that R2 is equal to 0.938, which means that 94% of the variation in total fat is explained by the linear correlation between calories and fat.
This is exam 2, question 19. We're trying to find the regression equation to predict the calories of a menu item from the total fat content. So the first step will be inputting the data into our calculator. So we're going to go to Stat, Edit, and list 1 is going to be the total fat, and list 2 will be the calories. And then next, we have to conduct a hypothesis test, and we start by defining the HO and the HA. So HO is P is equal to 0, and HA is P is not equal to 0. Next, we'll move on to the critical value. We are using a 95% confidence interval, so we have an alpha of 0.05, and we'll be dividing that by 2 because it's a two-sided test. So you'll go into your calculator, you'll click second, bars, then you'll go down to inverse T. So the area here will be 0.025 because you divided 0.05 divided by 2. And the degrees of freedom will be 2 because there are 4 data points for the 2 sets. So 4 minus 2 is 2. Then we're just going to click paste, enter, which will give us 4.303. So T is plus or minus 4.303, and then you have to draw in shade. So you'll put the plus or minus 4.303 and shade both sides. Next, we'll move on to the test statistic. So we're going to find the test statistic by doing the linreg t-test. So we'll go to stat, and then we'll go over to test, and then go down to the linreg t-test. Okay, so x will be list 1, and y will be list 2, and the frequency is 1. Then we calculate to find that the test statistic is 5.546, and then we are going to move on to the p-value, which you can see here is 0.031. So because our p-value is 0.031, it is smaller than our alpha of 0.05, so therefore in step 5 we're going to reject HO. And then our conclusion says there is sufficient evidence at the alpha of 0.05 level of significance with a p-value of 0.031 to suggest that the data are linearly correlated.